Okay. All right, today we're talking about circles. And let's start with a basic definition for a circle. The locus definition is all points equidistant from a point. So here's our point, and every single point is equidistant to that. Here we have a radius. Radius is from the center to the edge of the circle. The center is the fixed point in the middle, and the diameter is twice the radius. That should be review. Now the center radius form is listed x minus h quantity squared plus y minus k quantity squared equals r squared. R is the radius, the center is h comma k. We're going to develop that later in the lesson using the distance formula. So, to start off though, if I was looking for what is the radius in the center, my first example, the radius is equal to the square root of 16, because the radius squared equals 16, so the radius is 4, and you can't have a negative radius, so that's positive 4. The center is, according to the rule, the opposite. And when we do the distance formula, you'll see that, so it's 2, negative 4. Next one, the radius, or r squared, is equal to 25. So the radius itself is equal to 5. And then the center is negative 3, 8. Next one, write the equation for a circle centered around C25 with a radius of 7. So then we would want to take and do the opposite. Okay, so it would be x minus 2 quantity squared plus y minus 5 quantity squared equals 7 squared, which is 49. Write the equation of the circle through the point 0, negative 3, centered at C06. Center radius form and standard form. Okay, so centered at 06 means we're going to do x squared plus y minus 6 quantity squared, and that needs to equal our radius. So, I mean, it's a pretty easy one without using the distance formula. You can go over here to 0, negative 3, and 0, 6. Okay, so if this is the center and the equation is going through the point 0, negative 3, this would be the radius. So how much is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 squared, or I don't even need parentheses around that. So let's take that away. So it's just x squared plus y minus 6 quantity squared equals 81. That's center radius form. Now, standard form would mean to multiply that out. So it would be x squared plus y minus 6 times y minus 6 equals 81. And then we'll subtract that 81 because it needs to be set equal to 0 to be put in standard form. So let's clean this up. X squared plus y squared minus 6y plus 36. Subtract 81 and then combine some like terms. So 8x squared plus y squared minus 12y minus 45 equals 0. And that's standard form. Okay, the next page we're going to see how this was derived. So, I'm going to say that P1 is the center. Okay? So this is the center. So X1 is basically H, and Y1 is basically K. And then P2 is just a point. So if I am looking for the distance from the center to the point, I'm looking for the distance P1, P2. Then that is equal to the square root. The distance formula is change in x's squared plus change in y squared. So you can do x2 minus x1 squared plus y2 minus y1 squared. Okay. And then if I take and I square both sides to get rid of my radical, now this distance, remember, is really the radius. So the radius squared becomes, and the square root goes, because we're taking and squaring a radical, like with the radical equations. So we end up with x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then remember your hk, h represents x1, so your radius squared is equal to x2, which is just, I'm just going to turn that into x. x1 was equal to h. And then y2 I'm just going to turn into y because I'm replacing y1 with k. So, you know, this was x1, y1 over here, h and k. So that's how I get my equation. So find the distance between P1 and P2. This next one. So the P1, P2 distance is going to be the square root of change in x. Now another way to do change in x squared is triangle x plus change in y, which is triangle y squared. That also means x2 minus x1 quantity squared. You could do x1 minus x2 quantity squared as long as you do y1 minus y2. I'm doing y2 though, minus y1 quantity squared. Those are the same. So if we take the change in the x's, and it has to be in the same order, so if I go negative 3 minus negative 8, and then I go 5 minus 10, should be the same no matter what. You know, this could be like x1, y1, x2, y2. Negative 3, 5 is x1, y1. Negative 8, 10, x2, y2. And so then I get negative 3 plus 8, which is just 5. And then I get, oops, this one's squared too. So then I get negative 5 squared. So that becomes 25. So I really have 5 squared, which really just becomes 25. And I have still the square root of that, which is the square root of 50. Okay, so that's the distance. Or we could say that it's, let's see, we could say that it's 5 radical 2, square root of 25 and 2. All right, so that's your distance for P1 to P2, which would be your radius. Okay, so now find the equation of the circle that is centered at P1. So the center is P1, which was -3, 5, and goes through P2. So we know that we have then the radius, which was equal to the square root of 50 or 5 radical 2. So now I just need to put it into the, let's put it in center radius form. So it would be x plus 3 quantity squared. Because, all right, so if h here, all right, it was h comma k, but we have x minus h. So we have to take the opposite of h, the opposite of -3, and put this in. X plus 3 quantity squared plus y minus 5 quantity squared equals the radius squared. So that's going to be square root of 50 squared. Well, what's the square root of 50 squared? Just 50. So that is my equation, center radius form. All right, next part we're going to be looking at hopefully some review here on completing the square. Here's your standard form. We already did a standard form problem. We set it equal to 0. Now, so sometimes you're going to be given them in standard form, and then you need to be able to figure out what the center and the radius of the circle are based on completing the square. So I've got some steps for completing the square. So remember, what you do first is you set it up as x squared plus something x. If I take from this equation dx, okay, then you're going to do plus blank. Switch colors, and then we're going to do plus y squared plus ey. E is, I don't know, it's whatever number in the problem, plus blank equals, and on the other side, you would put -f. You would subtract f. And then you would have plus whatever you added on that left side also needing to be added on the right side. Now, to get what is added on that, added to the end of that, we take d, I'm going to put it in a different color. Put it in green. So we take that coefficient divided by 2 and square it, and that's what goes there. And we take e, whatever that coefficient is, divided by 2 and square it, and we put that there. And then we do this, we add that same amount on both sides. Then, so that was really kind of like step 2. And then step 3, you're going to factor this one, okay, plus, and you're going to factor this one. So you've made it so that you're going to have these trinomials be sides of squares. So when you factor them, they should be the same. They should kind of turn out to look like, the same thing squared, something in there squared, and then something in here squared. And it's going to be like x plus something, or x minus something, and y plus or minus something. And then that's all going to equal you know, you're going to combine that right-hand side. So whatever that right-hand side is. So negative f plus whatever was there plus whatever was there. And there you're going to have your radius squared. Okay, so this right-hand side is going to be the radius squared, and you can figure out your radius, and then you'll figure out your center. So it's going to turn out to be, this will end up being, you know, x minus h quantity squared, so whatever number you get there. And this one's going to turn out to being y minus k quantity squared, whatever you got there, equals, and the right-hand side will turn out to be your radius squared. And there's the equation, and then you can find your center and radius. So let's try it. So I'm going to take x squared plus 4x plus blank, put those together, plus y squared plus 6y plus blank. And that's going to equal 3 plus whatever is in the green and whatever's in the blue. So to find that value, we're going to take half of 4, square it, and that's what goes there. So 4 divided by 2, 2 squared, 4. Here we're going to take half of 6, square it, and that goes there. So 3 squared, 9. So now I'm going to add 4 and 9 to the right-hand side. So I'm going to factor x squared plus 4x plus 4, but it's a perfect trinomial. So it should factor, to x plus 2 times x plus 2, which is really just x plus 2 quantity squared. See, these are, you're completing the sides of a square, x plus 2 and x plus 2. And then the next one for the y squareds, that's going to be y plus 3 times y plus 3. Or plus y plus 3 quantity squared. And then that's going to equal the sum of 3 plus 4 plus 9. So 7 plus 9 is 16. So there is the center radius form of your circle. The center is -2, -3, and the radius is 4. So one more to try it on. So I'm going to go x squared minus 2x plus blank plus y squared minus 2y plus blank equals, I'm going to bring that 7 to the other side and do plus the blue plus the green. I'm going to do the same thing. I'm going to take and go back here and go -2 divided by 2 squared. That's going to be +1. And then I'm going to take -2 divided by 2 squared. That's going to also be +1. So I'm adding 1 and 1. I have to keep an equation in balance. If I add something to one side, I have to add the same amount to the other side. Now I'm ready to factor. So it's going to be x minus 1 times x minus 1, which is really just x minus 1 quantity squared, plus y minus 1 times y minus 1, which is really just y minus 1 quantity squared. And then that equals 9. So there's my center radius form. My center now is 1, 1, and my radius is 3. So that's how we use completing the square to write equations of circles from standard form to center radius form. All right, that's it, I believe, for the night. So good night.